So pretty excited to kind of discuss this topic today, which is RESTful APIs as my screen loads. We're going to talk about some objectives, which is first off kind of covering what is REST and what is an API. So we'll start with some definitions. Then we'll transition into, how do RESTful APIs work on the web? What is the role of RESTful APIs in web communications? Then we're going to talk about the REST principles. And so REST is kind of considered an architecture. And if you're going to build a RESTful API, what are the principles of that architecture? And then we'll get into some design rules so that we can design REST endpoints with good practices, right? So it turns out there's RESTful APIs that can be built that don't follow good practices, and then there's, of course, the opposite of that. They could be built. There's actually levels to it. There's levels of level 0 is no good, level 1's better, level 2, level 3, level 4. So there's levels to it, and you can level up your RESTful APIs. So kind of starting with the definition, you've probably, by this point, I hope you've heard the term API, although it's probably, I don't know, just my own understanding is do I understand this? Do I understand what an API is as I was learning development? I've heard it a bunch, but do I really understand it? The technical definition there, application programming interface, and I will tell you my own evolution is hey, I always thought of an API as a library of code. And I still think that's a good definition. Someone's going to write code for you to use, and if you use that library of code, you're using an API. Okay, so if you think of we got a library right across the way, there's a library of books. Okay, so you can go check out any book. It's a bunch of pre-written books, and you could just check it out and read the book. Okay, well, an API is a bunch of pre-written code that you can use. And so, my own understanding, one of the first APIs I ever used was the Java API. Now, you've probably heard of the Java programming language. It was crazy popular in the 90s, and there's a lot of Java jobs today because it was the dominant language for 2 decades. Okay, Java, today's standards, is kind of considered kind of old. If you go work in the industry on Java apps, it's kind of a dated technology in a lot of ways today. But what you would do with Java is you would download the software development toolkit, you would download the SDK, and then you would use all this pre-written code to build Java apps. And so Java, if you're going to build a Java piece of software, you would download the API, if you will. You would download all this pre-written code, and then you would get to coding using those objects and using those methods. Okay? Well, that's an API, pre-written code. It's a library of pre-written code. That's how I think of it. I think that's how you could benefit from it. The technical application programming interface, okay, memorize that or not, I don't know that that's going to benefit you. But it's a library of pre-written code. Then what does RESTful mean? Okay, again, REST, representational state transfer. The technical, what does those letters stand for? Okay, which is a set of rules for designing, networked applications. I'm gonna hone in on that keyword networked. Everyone can see the keyword network there. Okay? Well, see, Java is so old school, the applications you would often build with a Java app, they would be a desktop application. Okay? And it could be networked. It could communicate across the network, or maybe it didn't. Maybe it just ran locally on your computer. Okay? But the reason I'm going to hit that networked application is if you have an application on the internet, well, the internet's the biggest network that exists, okay, that's where your API can be RESTful. Okay, so the way I tie in the word RESTful is if your API is on the internet, if your library of code is on the internet, then it's probably, most likely, the odds are, it's a RESTful API. Okay, and that just means that this API can go on the internet. It can communicate across the internet. Okay, so it's a library code that communicates on the internet. The first time I saw this, I was like, okay, well, how do I want to think of this? And I wanted to think of it as, well, you take a method, like everyone understands what a method is or what a function is, and if it's accessible on the internet, okay, that's kind of a RESTful, that's how I thought of it. Okay, just any method that's accessible on the internet, because an API provides access to methods, and it's a method accessible on the internet. That's a RESTful API. So you will see, so hopefully this is going to make sense. Okay, and a RESTful API is just that. It's a library of code accessible on the internet. Now, you're going to see the terms REST versus RESTful. I just have that little third term in there. They're both fine. Okay, I'm going to use those terms interchangeably. You could get a little bit technical and say RESTful is like, yeah, you're really following these principles of the architecture, right? If you read into that, and whereas REST API versus RESTful API, it just boils down to they're both correct. You could use either one. You want to get a little bit technical, it's like, well, there are these principles of RESTful API, and if you're trying to meet all the principles and you're trying to follow all the best practices, then you could say, okay, RESTful. No big difference. So anytime I talk about a topic, it's like, well, why is it important? I think you guys need to understand the why. If we're going to study RESTful APIs, because frankly, this is how modern software is built. Modern software is built on the web. It's web applications. That is modern software. And modern software uses RESTful APIs. And so most APIs in the world today are RESTful, meaning they work on the internet. And, you can look at all these APIs that are made available. Google Maps, Twitter, Facebook, GitHub, YouTube, OpenWeather, Spotify, Stripe, Slack, Firebase. You guys have heard of all these companies, yes? Mm-hmm. Right? So their APIs, think of this. All their APIs are is like, here's some code that, Facebook makes accessible to us. Facebook makes, now some of their code, so obviously a lot of Facebook's code is not accessible to us. It's not open source. We can't see it, okay? But Facebook does make some code accessible to us. They want us to see certain things. They want us to see who's friends with who, and maybe demographics of different, people and customers, and that is a huge business, right? And they want you to, buy and sell stuff on their marketplace. And well, if you want to sell something and you're a company and you want to advertise on their platform, they want to make certain data accessible to you. Okay? So Facebook's API is basically what is the code that they make available publicly open on the internet. Okay? Is this hitting home for you guys or not so much? A little bit?
Yep. We use the OpenWeather.
Yeah, we use that last semester.
You've used the OpenWeather API.
Last year we used
Good.
the similar API.
Good. And you probably used Fetch. Did you use Fetch to make calls to the OpenWeather API? Does that ring a bell?
Kind of. I'm not sure exactly.
Okay. Okay. Now, that first bullet, what is the role of RESTful APIs in web communication? I really want you guys to hone in on this first bullet. RESTful APIs are used to create communication between the front end and the back end. I hope that makes a little bit of sense for you guys. Okay, the front end application, it can be something like React. Okay, and React is, as you know, kind of has components, and those components are sent down to the client. It's the HTML, it's the CSS, it's the JavaScript that gets sent to the client. Okay, that's the front end code. The back end code, as you guys hopefully know at this point, is Express. Express will be where we create our RESTful APIs. Okay? Now, basically, we need to enable communication between React on the front end and Express on the back end. So all of these right here, these open web APIs, they all are back end code that we can call from our front end. That's why you guys were sitting here saying, hey, from our front end code, we were calling the Open Weather Map API. That was a back end code. You were using your front end code to call the back end code, to create communication. Okay, you were hitting endpoints. So an example of this could be, you can go to nasa.com on your browser and that will give you front end code, right? So, or you could use another tool like Postman, and Postman can call NASA's API on the back end and receive JSON, right? So some servers will respond with HTML, CSS, and JavaScript. Web servers, right? Web servers, application servers can respond with JSON. So as we're gonna learn, APIs, RESTful APIs respond with JSON. Okay, so this is weird, right? Because now what we're finding out is that sometimes a client request can return HTML. Sometimes a client request can respond with JSON, right? So if you hit the web server, you're going to get HTML back. If you hit the application server, Express, if you hit the Express server, you're going to get JSON back. Okay, all these APIs, because they're RESTful, they respond with JSON. Okay, so RESTful APIs are used to create communication between the front end and the back end. Okay, that's an important concept to understand. The back end, Express, exposes endpoints, and the front end calls the endpoints to send or receive data. Okay, so all right, here's another thing I want you guys to realize. All right, we've already coded some REST endpoints in Express. Okay, so we were doing some of this without even really calling it what it was. Okay, now we're just kind of putting a name to it, right? But when we did /products and return JSON from our mock database, which was an array of products, right? You guys had a hands-on test on this, right? You guys had an endpoint and you used Postman to call that endpoint, and that endpoint returned products, right? It returned entities, if you will. Okay, so you've kind of already done this. We're just kind of diving the next layer deeper. Okay, yeah, please.
What's the difference between what's the difference between an API and like a web service call?
The difference between an API and a web service call.
I remember I was talking about that. He was like specific on like the web service call.
Yeah.
They seem to do the same thing.
Yeah, well, I think a web service call can use an API, right? But I don't think it has to.
That's what I'm getting.
Is that your APIs?
They can function online or offline. Web services require a network to function.
Okay, thank you for that. Yeah, so APIs, okay, let's hone in on that, right? APIs can act online or offline. That was my example of the Java API. That didn't have to be online, whereas web services do have to be online, right? So thank you for that. And that makes sense now that you kind of give me that little carrot there to lead me in that right direction. Okay, so I mentioned that RESTful APIs are this architecture, so there are principles of this architecture. Now, there was a guy by the name of Roy Feeling, so it's just kind of one of those things that when were RESTful APIs invented, remember that the internet became popular in America in the 90s, right? And so in the 90s, no one knew what they were doing on the internet. No one understood the internet. It's kind of like cryptocurrency today. No one really understands it by the mass population. But nowadays, it's everywhere. So REST only came around 2000. A guy by the name of Roy Feeling he wrote a dissertation paper and kind of defined what this is. So these principles were defined in the year 2000. So where were you when RESTful APIs were created? Like this is, you know, I guess I just want to give you the source of where these principles come from. This was essentially like a grad school paper by a really smart guy. All right. And so kind of starting number one, everything is on RESTful APIs are referred to as resources. So whether we're talking about products or users or orders, you know, these endpoints work with resources. So they work with your things, right? Typically your things exist in a database, right? That's the typical, you know, case, is that your resources are in a database of some sort. In our case, you know, there's all these databases, but in our case, our database is Mongo. Okay, it is also true that REST works with HTTP methods. So what methods have we used? You guys remind me of the methods. So these are verbs, right? These are actions, and you've heard put, you heard HTTP gets, right? So I remember said get is kind of like the reading of data. The put was kind of the updating of data. What are the other HTTP methods? Delete. What else?
Set.
Not update. Not set.
I'm cheating. I'm looking up Postman.
Yeah, look.
Did we say push?
Patch, if you remember patch.
Post.
Post. Remember post? Look at Postman, right? You got the drop-down list in Postman. What else? You said you're cheating, and let's do that, right? Let's pull up a request and look at. So we got get, put, post, patch, delete, and those are the main ones, right? There's head and options. I didn't use those either. Okay, so the point is, number one, we're working with resources. Number two, we're working across HTTP. Remember I said REST means on the internet. Anytime you see HTTP, that is the protocol of the internet. Okay, so if we're doing RESTful APIs, we're working with HTTP and we're working with resources. Big one, number three, stateless. Okay, I thought of a terrible dad joke. Maybe it hits. Stateless means client and server forget about each other. Okay, they have a one-night stand. All right, that's the terrible dad joke. The client says, "Hey, I want something to the server responds, and then they forget about each other. Okay, they connect one time and then they forget about each other. So they don't store information about each other, right? In a one-night stand, you do not exchange phone numbers. Sorry for taking that a level deeper, but that's the point. Okay, RESTful APIs are stateless, meaning the client kind of makes a request, one of those verbs, for a resource, and the server sends something back to the client, and then they forget about each other. And that's a principle of RESTful APIs. RESTful APIs are the equivalent of a programmer's one-night stand. Number four, we have URLs, more technically defined as URIs. You could see it either way, right? Uniform Resource Locator or Uniform Resource, I think I stands for indicator, I think. But the endpoints, the routes provide access to your resources. So via the route, you get a resource, and you might do an update, you might do a delete, all this kind of stuff. But the endpoints provide access to the resources. So there are resources, you're communicating on HTTP, it is stateless, they forget about each other. Number four, there are endpoints. Endpoints are for the front end. Remember, this is all about communication between the front end and the back end, right? The front end is going to call the back end endpoint. You with me there? The front end calls the back end endpoint to communicate from the front end to the back end. It's all about that communication. There are status codes. Hey, you know status codes. What are the status codes? Anything in the 200 level means it's okay. It's good. An interesting one that I put on here, 201, means resource successfully created. So in the event of a post, you guys remember a post is going to create a new resource. You would respond with 201. That means you created a new resource. That's a good one. The 400 level means basically a problem with you. There was a problem with your request. Okay, a problem with the client. 500 level is problem with the server. Problem with the server could be, you guys remember exceptions in C#? What were exceptions? What happens if you didn't handle an exception in C#? It crashes. Okay, so if your server crashes, an unhandled exception on the server, you're going to send back a 500. Hopefully you catch your exception and you can send a 500 error message back saying, something broke. Hopefully you catch your exceptions and you don't actually let the thing crash. Hopefully you handle your errors gracefully, right? Okay, so I don't think these principles are all too crazy. I think, there's resources, there's methods, it's stateless, there's endpoints, there's status codes, and it's built in a scalable way. Number 6 is probably the one I didn't hone in myself the most on. Let me read this. RESTful APIs are scalable and can be used across various platforms, blah, 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 as they rely on standard web protocols. Okay, what does that mean?
They're easier to expand.
Bingo. Yeah, I mean, one of the challenges, hopefully you guys have this challenge. One of the biggest challenges you guys are going to have is if your software ever takes off. And all of a sudden you go from 5 users to 1,000 to 1,000,000 users. Hopefully you guys work on a piece of software that scales, okay, from small to big. And as you scale, you need more resources, you need more RAM, you need more server, you need more compute, you need more power, you need more data center, you need more everything. So everything needs to be scalable, built in a way that can expand, okay? Because it will inevitably crash if you hit a good piece of software. So hopefully you have that problem. It's a great problem to have, but it's a problem nonetheless. And number 7 is that REST loves JSON, okay? Technically speaking, we're going to talk about levels, right? Levels of good RESTful APIs. It's like one of the early levels. Your RESTful API should send back JSON, okay? You don't have to. I don't know if you guys remember, like we first learned Express, we were just sending like hello world text message strings. Our RESTful endpoints were responding with strings, just text. But that's not what it should do. REST loves JSON, JavaScript object notations. They look just like JavaScript objects, right? Remember, JSON is formatted key value pairs. There's just no methods in JSON, right? There are no methods in JSON. It's just data. So RESTful APIs send back JSON, and that's a good RESTful API. Okay? So I wanted to send back, again, this is all about client-server response, right? And it's stateless, so they forget about each other, the one-night stand. The client is on the left, the server is on the right. At the end of the day, these are the messages that they're sending back and forth. The client says, hey, I want this endpoint, okay? And my method is a post. Those two things together are kind of called the start line, the endpoint and the method. The client also sends a really important thing here. This is why I put it on this slide, which is HTTP headers, okay? Which is like a little bit of what you would call metadata. What's metadata?
It's data that's not directly like shown, but it's about like the object.
That's right. Yeah. So the less technical definition, because you're right, is data about data, right? So a photograph is just that. It's a picture. Metadata is like, well, when was the photograph taken? And
Size.
What's its resolution? What's its size? How many pixels? Date and time object. That's all metadata. That's data about the photograph. The photograph is data. The data about the data is like all the extra stuff. The headers, the client sends a header. And what's really important here, because we're going to talk about headers as we get into this, we're going to be working with client headers because you also need to provide authorization. In other words, do I have permissions to access this resource? Right? Am I an anonymous internet user or have I logged in? And if I've logged in, because that's authenticated. I've authenticated, but am I also authorized? Am I authorized to access this resource? So all of this in the HTTP headers, a lot of this, the reason I point that out is because we will talk about headers in the future. And in the headers, we store our permissions that, hey, I'm an administrator, so I should have permissions to this resource. I should have permissions to this endpoint. And then the body, okay? So if you kind of break this down into 3 parts, you got the start line, which is the endpoint and the method. You got the headers, which really is metadata. It's like, hey, I'm sending you JSON. I'm sending you JSON. I want you to accept my JSON, and here's my authentication authorization, and here's the JSON, the body, right? And then the server, right? What is the server going to receive that request? It's going to run some JavaScript, application logic. It's going to read some data out of a database. It's going to perform some operations, and the server is going to respond with, hey, yep, what's 201? 201 we said is I created a new resource. Okay. Oh, maybe some server information, like, I don't even know. I'm just going to guess NGINX. I think that's like, maybe it's a Linux operating system. I don't know. It's a little bit about the server, like what operating system maybe. Okay. Again, just kind of metadata and then a response message that says, hey, this worked, So you kind of break this down. It's the same kind of thing the server sends back. We're going to send back a status code. Okay, we're going to send back some metadata, and we're going to send back some JSON. Okay, the important thing there is these little curlies right here that say status of success. That's a little JSON object that sends back to the client that says good job. Okay, so this is RESTful APIs. They create communication between the front end and the back end, and this is what the communication can look like. Okay, in a visual representation. Okay, so basically what we're going to do, I think you guys know this, we're going to perform CRUD operations. CRUD operations stand for create, read, update, and delete. So different endpoints will perform different operations. We've done this already, but what we were doing it on was on what I would call a mock database. What was our mock database? An array of objects, okay? That array of objects was just stored in RAM. Every time you rebooted your server, you reset your application. Okay, now we're just going to be working with actually Mongo, right? So that's actually the beautiful part of what we're about to do is we're just going to expand what we've already been doing, kind of following these RESTful principles, and we're going to tie in Mongo. So mapping CRUD verbs to HTTP verbs. And you can kind of see post is your create, get is your read. My evolution of this understanding, I will tell you, I learned something recently. Check this out. This is on, this chart was pulled, I should cite my source, but it was pulled from like Ray Fielding's paper kind of thing. The put method is where you're going to update a resource by replacing the whole resource. Whereas a patch, so an update is put, but a patch is also an update. Look at the patch. To update a resource by changing part of the resource without replacing the entire resource. Right? So if you're just updating a customer's last name, you're doing a patch. Right? But if you're replacing everything about that customer, it could be a put. It's almost like you're always using patch. Why do I say that? Well, when you insert a customer into a Mongo database, you get an object ID. If you're doing an update on a Mongo ID, right, you're not replacing everything. That ID is going to stay the same. Right? So in most cases, I think we should start using patch for our updates, right? Because again, a put updates the entire resource, whereas a patch updates just part of the resource. Okay, now what you're going to find out is that people do this differently. I'm just going off of the recommendations. Okay, so in the real world, you're probably going to find people doing puts, even though it's not replacing the whole resource. And that's okay. I'm just trying to do by the book, if you will. Okay, delete is obviously delete. Now the head, to get the response in the head but not the body. Well, okay, so what's the head? The head is this HTTP headers. So if you just want the header, but not the body. Okay, again, I can't say I've really used that too much. And then I have not also used options. But the main part there is post, get, put, delete, and patch. Okay, and kind of updating our definitions of what's a proper update look like. And a proper update, according to these definitions, probably are going to be using patch instead of put. So, if we're working with products, what might this look like? Well, if we run a get operation on /products, this would be a list of all of our products. Now, get a /product/ID is a single product. All right, so we're going to start talking about conventions here. And you're going to notice plural versus singular. Again, this whole plural versus singular thing is where you don't find consistency in what people do. Some people will recommend that everything be plural even if you're getting a single product. So in other words, some people would recommend /products/ID. Okay? I will show you why I landed on the singular version. To me, I'm a little bit, I don't know that I'm a real grammar Nazi, but to me, things that are plural should be plural. Things that are singular should be singular. So to me, this makes more sense. And again, I think we're going to get into some best practices where I can show you I'm not the only one. Notice our post is just a post to /product. Okay? Now sometimes, and we're going to see this, /product/create. You don't need that /create. All you need to do is say /post. And actually, I should get rid of that trailing slash. That's a mistake on my end. Put or patch is your update /product/:ID. What does the colon do? What does the colon do here in these cases? It looks for a variable. Yeah, it looks for a variable. And where is that variable sent from?
Mongo.
It's sent from, probably originally you're getting the ID from Mongo, but how is it sent from the front end to the back end? Well, in the URL, thank you. Right? This is what you would call this a route variable. Right? This :ID is what you would call a route variable. Okay? In Express, you would read that by rec.params.id. Remember that? rec.params.id. Okay, so this :ID, what that does is it makes your route dynamic. Okay, this route right here, /products, is known as a static route. It's static because it's the same thing every time. The second one, /product :ID, is a dynamic route because you can send different IDs via the URL. Right? So static routes, dynamic routes. Dynamic routes have route variables, is what that boils down to. And delete would be /product :ID. Kind of a similar thing here on the next slide. Really the only difference here would be it's common to add to your endpoints the API is part of the URL for readability purposes, right? Not necessary, but does it make sense? I think so. Anytime you're accessing API endpoints, to add that prefix to your endpoint URLs. Okay, so just putting that API on there for customers. And again, if I'm just looking at that first one, I've seen that first one, /API/customers. I've seen that as /API/customers/list. Okay, you're going to find out that the operation It's not a best practice to put the operation in there, like getting a listing of customers or creating a customer or deleting a customer. You keep that off of the route. And you let the method dictate the operation, the verb, if you will. So as we are going to transition from this lecture into writing code and building our own RESTful APIs, there will be some design choices. There will be some choices we get to make about what are our endpoints and how do they work. And so we're going to talk about some design rules, right? How should we design our RESTful API endpoints? How should they work? And so there's a whole list of benefits. And admittedly, this is like the worst slide I've ever created because just read it. You don't need to hear me, verbally, read this to you, but go down the bullets and just look. I mean, there's a lot of benefits to good RESTful API design. Blah, puke it out on the screen. Usability, maintainability, security, performance, reduced development time, scalability, reusability, better documentation. Every one of these is a valid point. Every one of them should be taken into consideration. Big picture, like there's some rules that we're going to learn, and this is why those rules are important. And it basically comes down to building good software. Okay. So what are these rules and what are these guidelines that we're going to follow? And I put little screenshots in here to try and clarify what these rules mean. Number one, collection resources should be plural. Okay, and so again, I'm going to be updating how I've taught this in the past. I'm going to be following, these are the rules I plan on following. And so for example, collections, you guys know what collections are. We just studied Mongo, right? Databases have collections. So if you have a collection of teams, right? The green means good, the red means bad. Teams is plural because it's a collection versus the singular team would not represent a bunch of them. And so this would be the list of, players on that team kind of thing. The green's good, the red would be bad. Now, singleton resources just means there's only a single entity that exists. Okay, because we're working with resources. If you're working with teams, that's a bunch of things. If you're working with a single player, getting a player by its ID, that's where you have that route ID that we talked about. Okay, so we already talked about this. I will note my mistake on my prior slide. I believe if you go back, I didn't have that plural. So the collections, like here, the get, this should be products. Okay, I think I'm logged in. Am I logged in? I'm not logged in. If I log in here, I can edit this. Okay, so if I'm following the design practices that I'm covering now, this would be products because it's a collection, getting a single ID. Again, I'm just referencing this slide right here. Yeah, it should be the same for post and everything else, right? So yeah, good question, right? So post would be /products and no trailing slash. Products. So that kind of makes all of our collections plural. Okay, now again, you're going to see this done differently. The important thing is that we pick a solution and stick with it. So this is what I'm going to go with this time. Okay, and I can kind of show you the source of why, because this comes from here. This comes from the maturity levels. All of these rules that I'm talking about right here come from the 4 maturity levels. If this was invented in 2000, these maturity levels were invented later, call it 2010, and these are kind of being adopted as the different levels of good API design. Okay, so all of these URI rules come from here, and we're going to look at this in a little bit deeper case. Okay, so the important thing for us is to pick an implementation and stick with it. I'm not going to share. I need to click slideshow. Okay, collections are plural. Singleton resources mean only if one of these things exists, and you can make them in dynamic routes. No trailing forward slashes. Okay, I kind of have hit on that a couple times now. Interesting one because you could go either way. Using hyphens or underscores. According to these rules, which come from those levels, you want to use hyphens, okay? And the idea is that the hyphens are more readable than the underscore. I believe this is called, because you guys have heard of camel notation, you've heard of Pascal notation, you might have heard of, kebab notation. I think they call this one spine notation, like, your spine has discs and in between them there's little cartilage things. And anyways, nonetheless, regardless of the notation name or the naming convention name, hyphens instead of underscores improve readability. Lowercase letters, no uppercase letters. No file extensions. Number 7 is the one that I've updated my own. Again, I'm kind of, every time I teach this, I learn a little bit more and make improvements. Keeping the CRUD names out of the URLs. So on number 7, you notice the verb, the HTTP verb is delete. We're not including that in the URL. So we're using the verb, and this doesn't even make sense to me, to get something and perform a delete. I guess technically you could hit this route and perform a delete. It doesn't make any sense to me. You got the verb, use the verb. There are also, and we will use what are referred to as query strings, okay? Number 8, everyone kind of zone in on number 8. Notice the question mark there. You've seen this before. Anything that comes after the question mark is called a query string, right? These are variables that are in the URL. These are variables that are in the URL that are not route parameters. They're just other types of variables. Okay, so just recognize what a query string is, what it is, and so what I see these query strings doing a lot of times, not necessarily including the role, because that should be in the header. In reality, you want to put that in the header, but you can put things like paging and sorting up in the query string. And so you guys have all seen paging controls and sorting controls, like these grids of information, and you want to sort by last name. You could put that up in a query string. It's a good example of where that comes useful. And they show an example of that, right? Query strings with paging and how many items per page kind of thing. So these are our URI rules. It really comes from this article right here. You guys can kind of click on this and get through the 4 levels of maturity in REST API design. This is for reading. Really, I don't need to hit this all right now. To get to level 2 isn't that hard. Okay, to get to level 2 isn't that hard. Level 0, it says the swamp of pox. What in the world is the swamp of pox? That means you're using XML. And we're not using, in other words, you're at level 0 if your server is not responding with XML. We're not going to respond with XML. I'm not going to teach you how to respond with XML. So boom, we're at level 0. Okay, we're only going to respond with JSON. We're at level 0. You're at level 1 if you're working with resources. Well, that's all that we're going to learn, right? We're only going to work with resources. We're going to work with customers or products or tickets or bugs. Those are our resources. Level 2 is a little bit deeper. So the swamp of pox I explained. Remember this? Hyphen should be used. Oh, spinal case. There it is. Spinal case. Okay? You guys notice these rules? Underscores not used in URIs. Lowercase letters. You guys see where I get these rules from? File extensions not used. Okay, so those rules, I said it's all about XML. That's not true. It's to get get to level 0, you have to send JSON and use hyphens and not use underscores and use lowercase letters, file extensions. Okay. Level 1, they have these rules, no trailing slashes. You're going to use forward slashes. By the way, forward slashes fall forward. You can see that's falling forward. A lot of people confuse the forward and the backslash. Should an endpoint be named singular or plural? To keep it simple, I really like this part here. This is what I've struggled with because, again, maybe I am the grammar Nazi. In my own head, I'm a grammar Nazi. Although your inner grammatician will tell you it's wrong to describe a singular instance of a resource using plural, the pragmatic answer is to keep the URI format consistent and always use plural or singular. So again, this is me updating my learning, and where I was calling a singular resource, slash whatever, singular slash ID, now I'm changing that. It's slash teams slash ID. Okay? And because I've updated my learning, now I'm going to be able to get to level 1. I guess before I was at level 0. So now I'm at level 1. Yeah.
Honestly, just to kind of understand better. So say if you're hitting a route
Yep.
that is plural.
Yep.
They're saying choose either one or the other. Don't go back and forth with that.
Yeah.
You're hitting
They're saying keep one.
bugs, but they want you to either keep
It does say always either use singular or plural. We're going to go with plural. Yeah, and it says not having to deal with odd, like person and people, goose and geese, right? Makes the life of an API consumer better. Blah, blah, blah. And here it comes down into an opinion. I personally like the singular way. Anyways, I think at the end he says, pick. You're more than welcome to use either one, plural or singular, at your own choice. Just be consistent.
Okay.
Just be consistent. Does that answer your question?
Yes.
Great. So we're going to choose plural. Okay. We talked about the methods, using your methods. Again, a patch is updating a part of a resource. A put is updating the whole resource. Yes? You could use both. Yeah, you could use both. The thing that I got to figure out for me is if you're replacing a whole resource, to me that would include its ID. You know what I mean? The user ID. And typically you don't update the user ID. That's like what it is. So that's where it's like, anyways, maybe that's making it more complex than it needs to be. Okay, we talk about headers. I like this piece right here. Just as a reminder, probably the most important thing in the header comes from the client to the server, is going to be some authorization information. As a client, am I authorized to access this endpoint? That's going to be a big part of what we do. Okay, you also get a header in the server response, query parameters, status codes, okay, created. Now, again, something that I learned along the way, I used to, for example, I would create a new resource, I'd create a new customer, and I'd send that customer information back to the client. I would say, Bob customer was created, Bob's address, Bob's whatever, all this customer information, I'd send it back to the client. And that's generally not a good practice. You just want to basically send a 201 success message, like customer created, not sending the whole data back to the client. So just some more status codes. Again, we will dive into these deeper as the semester goes on. What's the difference between 401 and 403? And you guys all know 404. Okay, and I would say it should be very feasible for us to get to level 2 without too much challenge. Most APIs, my understanding is they fall apart on level 3. Most of them can get to level 2. Level 3 is where it falls apart. And, well, frankly, I don't think... we will get too much into level 3. Level 3 is when you start sending back, like, this kind of stuff, where you might have the URL for a video or a URL for like an image. Maybe we get into this, but and start talking about API versioning. And so APIs, there are software. Softwares have versions. And so when you have a front end that calls a back end, if you change the back end, you probably also have to change the front end. And so it is a bad day when back ends change and they kind of break a lot of front ends. And so there's a whole strategy around, like, this is version 1 of my API and this is version 2 of my API, so that you don't break version 1 front ends by creating version 2, you know. So, you know, I hate saying that we won't do any of this, but I do think it is a real world case where most backend APIs can get to level 2 without too much challenge, and they kind of fall apart on level 3. That's my understanding. Moving on, okay, and we already kind of talked about this a little bit. REST APIs love JSON. Again, the server should respond with JSON. That's all we're really going to do. We already know this, blah, blah, blah. The one kind of term that I throw in here is AJAX, right? Stands for asynchronous JavaScript and XML. In the old days of the web, if a single piece of the page would update, it would cause an entire page refresh, okay? Imagine Gmail in the early days. If you got a new email while you were on that home page, you would have to refresh the page to see that email. Okay, nowadays, if I'm on my Gmail, you know, I get a new email, it just pops right up. I don't need a page refresh. It just pops up. Okay, that's AJAX that enables that client-server communication and page refresh without an entire or portion of the page refresh, without the whole page refreshing. Okay, the point I want to make here is that AJAX enables that, and we will use Axios from our front end to call our backends, and Axios implements AJAX. So we're going to be able to do these like partial page refreshes. You know, it's going to be a modern web experience because we're using Axios. Axios uses AJAX. That's what AJAX stands for. AJAX stands for asynchronous JavaScript and XML. But we don't use XML, we just use JSON. So it's asynchronous JavaScript. You guys know asynchronous JavaScript, and we use JSON. Okay. And then here's kind of a dump of different resources. The one I'm going to click on, I kind of already linked if you guys saw this. API vault.dev. This is a world of public APIs. Okay, so last semester you guys messed with the weather API, but there are many APIs on the web. Some of those APIs we were discussing on break. Some of those APIs are open, they're free. Okay, but you know, the controversy of like, I guess a year ago was Reddit as one company, you know, started charging metered access to their API, right? You guys might remember that, right? The more you called their API, the more you had to pay. So there are also closed APIs that you have to pay for on a per use basis. There's also APIs that, you know, you just might have internal to your company. There's all sort of APIs. I do want to mention the old standard is SOAP. SOAP is the old standard for an And SOAP worked more with XML, and it worked with JavaScript objects kind of built into the JavaScript language. And so SOAP was the old way of doing these operations that we're now doing RESTfully. Okay, so just as another standard that you may come across is SOAP versus REST. API Vault is just kind of cool. You can kind of like look at, I don't know, if I want to do something with blockchain or there's all sorts of companies out there that put out fun facts. You know, I don't know. Nonetheless, there's fun ones like Chuck Norris, where you can send requests to certain endpoints, and you get back images and quotes from Chuck Norris, funny things about Chuck Norris. There's Pokedex API, that's a fun one. You can just kind of call on different API endpoints and get back different Pokemons with their images and their powers. There's exchange rate APIs for exchanging US dollars into pesos or whatever you want to exchange. There's NASA. Remember, I used the NASA one. You can get some different NASA endpoints. Sometimes all you need is to register. Many times when you register for an API, they're going to give you a key. Okay, and you need to use that key. That API key is very equivalent to a password. This is your password to access their services. So keep in mind, anytime you have an API key, this is something that is a secret. It is like a password. This is unique to you. Okay, because if someone else gets your API key to a metered API, you know, they're going to be charging up your bill. Not a RESTful API. RESTful APIs you'll need to do on the internet. I hear you. I think to break down, you know, kind of how I did is like an API is one thing, but a RESTful API specifically says an API on the web. You know, so these are just different endpoints, and again, you can generate your own keys. They'll give you a key, and just treat that key like your sensitive password. Because if someone gets access to your account, they can run up your bill. You know what I mean? So there's that. And I say, now let's build one. Okay? So here's what we're going to do. Here's the exercise. We're going to continue working on, whatever that dog walker app was, that mock app. And I'm going to kind of stop this lecture portion of the video here, and I'll resume working on, I think we called it Tail Runner.